Hey Algebra, today we are starting on Chapter 7, which is Polynomials, and very soon we'll be getting to do all the fun factoring and stuff that I've been talking about for so long. We're going to start out with some definitions, so you're going to need to pause the video wherever necessary to take notes. Yes, you do have to take notes. So we'll start out with terms and factors. So terms are when values are added within an expression, whereas factors are when values are multiplied within an expression. So an example of terms would be this: 3x squared plus 7x plus 6. So in this case, 3x squared is a term, 7x is a term, and 6 is a term. For an example of factors, in this case we have x minus 5 in parentheses times 3x plus 2 in parentheses. Both of these are factors. X minus 5 is a factor, so all of this, and 3x minus 2 is a factor, all of this. So the word polynomial comes from the roots poly and nomial, poly meaning many, and nomial meaning names. There's different kinds of polynomials, and they all have different names. However, we're just going to start with a monomial. So a monomial has just one term. So an example of a term could be a number, a variable, or a product of numbers and variables. So examples could be like the number 5, it could be a monomial. The term 3x squared could be a monomial. It could also have multiple variables like 7xy, and it can be a product of 3 different things. However, since they're all being multiplied or divided, they're considered one term. So these are not being added or subtracted, I just have them separate, so just imagine these are all individual: 5, 3x squared, 7xy. We also have binomials, which are 2 terms. So an example of a binomial might be 3x squared plus 5, or 7x minus 2, or 10xy squared plus z. These are all binomials because they have 2 terms. They are all being added or subtracted. So you see, here's 2 terms, here are 2 terms, here are 2 terms. So as you might guess, a trinomial has 3 terms. Examples of that could be something like this, which has 3 separate individual terms. You get the idea. So those were all types of polynomials. Now we're going to talk about degrees of polynomials. Now we're going to talk about degrees of polynomials. The degree of a polynomial is determined by the highest exponent in the expression. So we're just going to start by going through the degrees of polynomials, and I hope you'll see what I'm talking about. So here, a polynomial to the 0th degree is called a constant, which is just a number. So 7 is an example of a polynomial of the 0th degree. The reason it's called that is there's a secret variable here, so you could imagine any variable you wanted, and you would raise it to the 0th power. And remember that anytime you raise anything to the power of 0, it just becomes 1. So this is actually saying 7 times 1. So in reality, we do not need to write this part here, but we do know that this 7 is multiplied by a secret variable to the 0th power. A polynomial to the 1st degree is called linear, and this is where we go back to our famous y equals mx plus b, all those equations that we spent time graphing, and if you remember right, all of those graphs were lines, which is why it's called a linear function. So an example of a linear function would be 3x plus 7. The reason that we call this a 1st degree polynomial is because this x here, even though we don't write it, is raised to the 1st power. And remember that we determine the degree of the polynomial by the highest exponent, which is why we don't worry about the degree of the 7. Now we're looking at the highest possible exponent, which is 1. A 2nd degree polynomial is known as quadratic, which I know it doesn't make a lot of sense because quad is the root for 4, but that's just how it is. So the 2nd degree polynomial has the highest exponent value of 2. For example, you could say negative 9x squared plus 3x plus 7 is now a 2nd degree polynomial. So the highest exponent in this case is 2, so this is a 2nd degree polynomial. With 3rd degree polynomials, we go back to making sense because the name for it is cubic, and cubic means 3. So for example, we could have a polynomial that looks like this here is a cubic polynomial. It's made up of 4 monomials, this, 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 and this, and the highest degree exponent is 3. We don't need to know the names of any of the higher degrees, so we just go ahead and say, all right, a 4th degree polynomial would be where the highest exponent value is 4. This here would be a 4th degree polynomial because the highest exponent is 4. Your homework may ask you to identify the type and degree of the polynomial. So here's our example, 3x to the 4th y squared plus 7x squared. So the first thing we're going to do is tackle the type of polynomial, which is asking us how many monomials make up this total expression here. How many terms are there in this? We see that there's 2 terms separated by a plus sign. So because there's 2 terms, we identify this using the notes that you definitely just took as a binomial. Now we have to identify the degree of the polynomial, which means we're looking for the highest exponent level. Just because this has 2 variables, that doesn't make a problem. We don't have to differentiate between x's and y's. We can just look at x to the 4th and say that's the highest level of exponent, and therefore this is a 4th degree polynomial. So when we're writing it out, we could say this is a 4th. So when we're writing this out, we can just say 4th degree binomial, and then we're done. So your homework may also ask you, what is the leading coefficient of the expression? We remember that a coefficient is just the number multiplying any variable expression. So there's 2 coefficients in this expression here. The coefficients are positive 3 and positive 7. Which one is the leading coefficient? It's the coefficient of the highest degree term. So in this case, because x to the 4th has the highest exponent, the leading coefficient will then be 3. You should also be able to know how to write polynomials in standard form. So this means there's a specific way of organizing polynomials that will be used in pretty much all math textbooks. We're going to start off with all like terms combined. So in a standard form polynomial, you make sure that you've combined all like terms. The second criteria for standard form is that the exponents decrease in degree from left to right. And we'll do an example of that in just a minute. So the last criteria for standard form only really works if you have only one variable, and I believe your homework will only be using one variable when it asks you to do this. But the third criteria, which is if the polynomial contains only one variable. So let's do an example of this. Let's rewrite an expression in standard form. Here we have a polynomial that is completely out of order. We also see that there are terms that have not been combined. So we're going to actually go ahead and worry about combining like terms first. I notice that the only terms that can be combined are negative 5x and negative 8x. Everything else has a different level of exponent, meaning that it cannot be combined. So none of those terms in the middle can be combined at all. So we're going to just go ahead and take negative 5x and negative 8x and add the coefficients. This is going to become negative 13x, negative 5 plus negative 8. So we're going to rewrite this. We'll just combine it on the left side for right now. So we'll get negative 13x plus 7x to the 4th, like this. So we've combined all like terms. Now we have to rearrange them in order of degree. So in this expression, the highest degree is 4, so this value is going to come first, and then we just descend from there. So we have an exponent of 4, 3, 2, 1. And what we can do is we can just take all of these terms, and we make sure that we take the sign with them. The sign of the coefficient is important, and if you don't move the sign with your term, you're going to rewrite the expression incorrectly. Once we've boxed everything in, we're just going to rearrange it in order from greatest to least, and have 7x to the 4th plus x to the 3rd minus 8x squared minus 13x. And this expression only contained one variable, so this automatically fulfills the third requirement. This is now written in standard form.